Right, so today we'll discuss 8 questions from December 2012 CSIR, and all of them are 2 marks questions. Okay, so never underestimate 2 marks questions, even they are the rank deciding questions for the entrance point of view. Right, so the first question is: a substitution of neta-5 CP group with nitric oxide is the easiest for. So among these 4 options, there's one option which actually fits for this particular nitric oxide group to be added in that particular group. Now, if you look at the electron count for the very first complex, it is neta-5 Cp2 iron. So iron is 8, Cp, there are 2 Cp's, so total 10. It is 18 electron system. Similarly, if you calculate for this, it will come out to be 10 plus 9 plus 1. Okay, 20. For this, it is 10 plus nickel is 8. No, it's 10, right? So 20 electron system. So this is 10 iron cobalt. So this is again 19 electron system. Now among 4, this is a stable 18 electron system. So you have to add your nitric oxide to one of these complexes. Now you cannot add to this because this is very stable complex. Okay, do not disturb a 18 electron system. So answer cannot be option A. Now among option B, C and D, to add NO, you should know what is the electron count for this nitric oxide. So we know that electron count for NO is either 1 or either 3. So for a linear system it is 1, and for a what is the other one, bent, for the bent NO it is 3. Okay, now see, once you add your NO, your resultant should be a stable complex. That means it should be an 18 electron complex. Now for this, if you add 1, let's say if NO is added in one fashion, so first you have to eliminate something to add NO, because it is a 20 electron complex. You cannot add again, almost it is unstable. Okay, so you cannot add without removing something. So even if you remove one chlorine, you will get again 1 Cp. You will not get a stable 18 electron complex. Like you have to go with hit and trial and see where does this fit best, so that your electron count will be an 18 electron. Okay, if you go for this, even here if you remove 1 Cp, what will be the resultant? 5 plus 9, 14, right? So 14, and if you add even NO3 bent, it will be 14 plus 3, 17. So even this cannot be your answer. Okay, so if you come to this particular complex, that is your Cp, nickel, and Cp again, this is a 5 plus 10, that is 20 electron system. Okay, now what you will do here is that to add NO, you just have to eliminate something before. Let's say we eliminated one Cp ring. So if you eliminate one Cp ring and then try to attach your NO, see if the resultant is a stable complex or not. So this is 5, this is 10, and if say NO is a bent mode 3, then the resultant is a 18 electron species. So this is the best fit. Okay, he is asking which is the easiest way of the substitution. So if you substitute in this fashion, you will get a stable complex. So your right answer comes out to be option C. Any organometallic question, if it is based on this kind of question like 18 electron is satisfied or not, or look always that if the formed complex is 18 electron or not. Based on that 18 electron rule only, most of the organometallic questions are asked. So it is very important for you to concentrate on 18 electron system and know what are the contributions of the ligands of a particular ligand when you are adding it to a complex. Okay, now the number of lines exhibited by high resolution EPR spectrum of the species. So what is the species? Copper ethylene diamine, that is NH2. Okay, I'll not write completely. Okay, NH2 and ethylene diamine, NH2 CH2 CH2 NH2. Okay, something like this. Okay, so structure is not important. What you have to know when it is an EPR question, you have to know the I values. Okay, so for copper, see, initially this is your central atom and it has one unpaired electron. Now that one unpaired electron is responsible for giving lines in your EPR spectrum. So that one electron, actually it gives one line. Okay, but once it combines with the nuclear spin of the copper, that is 3 by 2 as given in the question, So 2 into 1 copper, it combines with the nuclear spin 2Ni plus 1. So if you solve this, you will get answer as 4. So one line will split into 4 lines initially. Okay, and then what happens? Hyperfine splitting. This electron not only interacts with the nuclear spin of the copper, but also with the nuclear spin of the adjacent atoms which are present. That is 4 nitrogens. So 2 into nitrogen's nuclear spin value is 1 as given, and 2 into 1 into 2 Ni plus 1. So 2 into 4 nitrogen atoms, and I value is 1 plus 1. So 8. Okay, each line again splits into 8 lines. So each line you just write 8 for each. The total number of lines comes out to be 8 4s are 36. So what is the right option? Answer D. Okay. Now, the electric dipole allowed transition in a D2 atomic model system is. So for D2, these are all the possible terms. Okay. Now what is the electric dipole allowed transition? For that you should know the selection rule of electric dipole, that is delta S is equals to 0. For electric transition you should know that delta S is 0 and delta L is plus or minus 1. Now first look, where is delta S 0? Here it is not 0. Here also it's not 0. Among these two, delta S is 0. Both are 0. Now among C and D, where is delta L plus or minus 1? So for S, P, D, F, we know it is 0, 1, 2, 3. Okay, so for F and D, the difference is 1, accepted. For F and P, it's not 1, it is instead 2. So the right option is option C, because the difference has to be plus or minus 1, not 2. Okay. Now for water delta H vaporization, the molar entropy of vaporization is approximately. So what you have to find out? Molar entropy of vaporization delta S. So what is the formula? Delta H vaporization by TB. Now you have been given with the delta H vaporization 41 kilojoules mole inverse. And what is TB for water? It is 100 degrees plus 273, that is 373 kelvins. Okay, look at the options given, it is in joules, but the question is kilojoules. So just convert this into joules. This is very important when you solve the physical chemistry questions, because most of the times you don't look at the question given properly, and in a hurry we just solve it as the way given. So never do that. Concentrate what are the units given. The units are the most important. So once you convert this and solve for it, now 41 into 10 power 3 by 373 joules mole inverse K inverse. So these are the units asked. Now it is matching everywhere, so just simply solve this particular thing. Now if you solve this, the answer approximately comes out to be 109.9 joule mole inverse K inverse. Okay, that is nothing but it is almost equivalent to 110. So right option is option B. Okay. Now the Daniell cell is. So if you have watched my electrochemistry videos, you know that what is the Daniell cell, what are the ions involved in the Daniell cell. So what are the ions involved in the Daniell cell? It is zinc and copper. So in the options given, you can see that this is the option where zinc and copper is given. Here zinc Ag, iron copper, and it is H2 and copper. So what is the right option? Option A. Okay. If the concept of half-life is generalized to quarter half-life of the first order chemical reaction, it will be equal to. So firstly, what is the first order reaction formula? 1 by T ln A by A minus X. Okay. Now what he is telling that if the concept of the half-life is generalized to quarter half-life. So this is your quarter half-life firstly. Okay. So for a quarter half-life, what happens to the concentration? See, if the initial concentration is something like A, and after some time it is A minus X. Okay, so what he is telling, after some time the half-life is generalized to quarter half-life, so the concentration decreases to the 1/4 of the initial value. Okay, if initial value was 1, now it will be 1/4 of the initial value. So A minus X is 1/4 of your initial value. So what will be the resultant formed value, X value? It will be 3 by 4, right? See, if A minus X is 1 by 4, what will give you answer as 1? It will be only 3 by 4. So what is the left out concentration after the initial concentration has been reduced to quarter value of your initial concentration, the remaining concentration is 3 by 4. So simply substitute in the place of x 3 by 4a. So if initial concentration was a, then left out is 1 by 4th of a, that is, what is the remaining concentration? 3 by 4a. Now if you solve this particular thing, okay, k t half, I'll just take this over here, ln a by 4a minus 3a by 4, that is a by 4. So this will go in denominator. Okay, so this is nothing but ln 4. Can I write this? Yeah, ln 4. So what is your t half? T half is equals to ln 4 by t, no, ln 4 by k, sorry, ln 4 by k. Yeah, this particular option, right? Next, the angle between the two planes represented by the Miller indices in a simple cubic system. Very simple question, appeared many times in a CSIR, but sometimes in the exam we forget the formula. For that reason I have chosen this particular question. So what is the formula for the Miller indices? Like to find the angle for the given Miller indices, it is h1 h2 plus k1 k2 plus L1 L2 by square root of h1 square plus L1 square plus k1 square, h2 square plus k2 square plus L2 square. Now this is the formula used to calculate the angle between the planes given by Miller indices. Here h1, h2, h1, k1, L1. Okay, these are the values. This is h2, k2, L2. Simply substitute the values, you will get your angle from this question. Now, for an odd nucleon in G, the nuclear orbital and the nuclear orbital parallel to I, spin and parity are. So for an odd nucleon in G nuclear orbital, if G is the nuclear orbital, how is the orbital splitting for G? It is, there are 9 orbitals present, right? So for 9 orbitals, what is the spin value? 1 by 2 for each. So what is the total spin for each? 1 by 2 into 9, that is 9 by 2. What is the parity? Now how do you calculate parity? Parity is given by a general formula 1, it is 1 minus 1 power L. Okay, this is the formula used to calculate the parity. What is L? L is your azimuthal quantum number. So for S, P, D, F, G, what is your azimuthal quantum number L? 0, 1, 2, 3, 4. So minus 1 whole power 4. Okay, so minus 1 whole power 4 is plus, positive value. So what is the right option? It is 9 by 2, which is given in both the options, and the parity is plus. The questions are very simple, just that we do not practice the simple questions, and in exam we just get confused. Okay, so what is my request is, whoever is following my idea of short notes, just write down all these formulas in one particular page, and before you go to the exam, just have a view at all these formulas which will be for your exam. From my experience, I'm telling you that in the last moment, if you have a look at all the formulas which you have already practiced, that will really fetch you more marks in the exam. So do follow that short notes method and keep writing all the formulas in one particular page for the revision purposes in your exam, right? Thank you.